Hi guys, Digital Principal and Computer Organization. The subject code is CS3351 and this is the second part video in Unit 1 Combinational Logic. Demorgan's theorem. What is meant by Demorgan's theorem? In Demorgan's proposed the true theorem by using the NAND and NOR gate and negative OR gate and negative AND gate. So, De Morgan's first theorem is A dot B the whole dash equal to A dash plus B dash. A dot B the whole dash equal to A dash plus B dash. It was given in the words as the complement of a product of a variable is equal to the sum of the complement of the variable. So in LHS it will be mentioned with the help of AND operator and logical circuit. In RHS it is functioned with OR logical gate. So OR logical gate. So in the second point it was mentioned as the complement of the two or more AND variable is equivalent to the OR of the complement of the individual variable. It was mentioned as A dash plus B dash. This is the first theorem in De Morgan's. Truth table for this proves A, it has two variable A and B. So if we have two variable means we will get four values. A is filled with 0 0 1 1 and B is filled with 0 1 and 0 1 as an input. You need to find out the A dot B the whole dash value. First of all, you need to find A dot B the value. Afterwards, you need to give the complement to the A dot B value to get A dot B the whole dash value. 0 into 0 is 0. Complement of 0 is 1 and the complement of 1 is 0. If we give and 0 as input and 0 as input for B value, 0 as input means 0 into 0 is 0. So you need to give a complement for 0 value as 1. So first value is find out as 1. 0 into 1 is 0. Again you need to give complement for 0, that is 1. 1 into 0 is 0 and 0's complement is 1. 1 into 1 is 1 and 1 complement is 0. Finally, we will find out the LHS value. You need to find out RHS value and you need to compare the both the value whether it is equal or not. So to find the RHS value, first find out A bar value and B bar value, then do the addition operator in between this both value. 1 plus 1 is 1. 1 plus 0 is 1. 0 plus 1 is 1 and 0 plus 0 is 0. You will compare this both value. This is the RHS value. So this is 1 1 0 1 1 1 0 and this is 2 1 1 1 0. So both will be equal and this proof is correct and this proof will be used in the Boolean expression for simplification. This is the logical diagram for this equation. First of all, you need to draw the diagram for A dot B. Then you need to draw the complement of A dot B. So A dot B is draw by using the AND gate. Uh, this is A dot B. You need to do complement to this A dot B to get A dot B the whole dash. That's why you need to connect the AND gate with the NOT gate. This is the LHS value A dot B the whole dash or A dot B the whole bar. It is equivalent to A dash plus B dash. First, draw the values for A dash and B dash. So first you need to give the A as input and it is connected with the NOT gate to get an A bar as output as well as B bar as output. Both will be connected with the OR gate. And the final output is you will get as A bar plus B bar. And it is also called as negative OR gate because this is OR gate and it is connected with the NOT gate. So OR negative OR gate. NAND gate is equivalent to negative OR gate in De Morgan's first theorem. De Morgan's second theorem. This theorem is opposite to the De Morgan's first theorem. The complement of a sum of a variable is equal to the product of the complement of that variable. So, a plus b the whole dash is equal to a dash dot b dash. In first theorem, in LHS we will use AND gate, but in second theorem in LHS we will use OR gate, that is addition operation. In RHS, in first theorem we will use addition operation, but here we will use product method or AND logic gate. The complement of the two or more or variable is equivalent to the AND of the complement of the individual variable. Draw the truth table for De Morgan's second theorem. First of all, you need to give input for A and B values. Afterwards, you need to find A plus B. Then you will find A plus B the whole dash. This is the LHS value. Afterwards, find the RHS value, that is A dash dot B dash. Then compare the RHS is whether is equal to LHS. The RHS is always equal to LHS. As usual, filled A with 0011 and B is filled with 0101 and A plus B. A plus B, you need to do addition operation here. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1. So, just you will find out the A plus B value here, but you need to get A plus B the whole dash. It means you need to find out the complement value for A plus B. 0 is inverted as 1 and 1 is inverted as 0 here. Finally, you will get a value of 1, 0, 0, 0. Afterwards, find out the value for A bar and B bar. Then do the AND operation here to find out the RHS value. AND operation means that is product method. A dot B. So 1 into 1 is 1, 1 into 0 is 0, 0 into 1 is 0, 0 into 0 is 0. This value is equal to this value. This is the logical diagram of second theorem, De Morgan's second theorem. For LHS, you need to draw OR gate and afterwards you need to connect with the NOT gate to find out the A plus B the whole dash value. It is equivalent to A bar and B bar. A bar dot B bar. Draw the diagram for A bar by using the NOT gate and for B bar same as well as you will use the NOT gate. Then both will be connected by using the AND gate. This is AND gate to get an output as A plus A bar dot B bar and this is the negative AND gate. In second theorem, the NOR gate is equivalent to negative AND gate. Sum of product method. This is sum of product and product of sum. This will be two important term used in our K-map or in Boolean algebra in digital electronics. So sum of product means the two or three variable is product and they are summed with other group. So that is called as sum of product method. So the sum of product expression come from the fact that two or more product are summed together. So product by using the AND gate and summed by OR gate. And product of sum is method is opposite to the sum of product method. Here I will this is an example equation. So a plus b, it is summed and by and it is q equal to a bar plus b bar is summed and it is product with the another group. So product of sum method is opposite to the sum of product method. This both will be the example for equation of sum of product, and this is an example equation for product of sum. Next topic is Mnterm and Maxterm. What is meant by Mnterm and what is meant by Maxterm? In Mnterm, we will use the sum of product method to reduce our expression. In Maxterm, we will use the product of method to reduce our equation. Before that, you need to know what is meant by literal. Literal is nothing but the variable. For example, if you in some equation we will mention as a, b, c or x, y, z, a bar, b bar, x dash, y dash. These are called as literals. Here I will give an values for minterm and maxterm value by using two variable x and y. Previously I told you that minterm is based on sum of product method, that is SOP. In the minterm, the zero will be mentioned with the complement of the variable, that is x dash or a dash, and 1 is mentioned as the variable itself, that is x or y. The max term is opposite to the min term. The max term is based on POS, that is product of sum method. Product of sum method. Here the 0 will be mentioned with the variable as itself, that is x, but the 1 is mentioned as y dash. So min term is opposite to max term. Usually, if you have two variable means you will fill the truth table with first variable as 0011 and second variable as 0101. So min term, first value is mentioned with m0 and second value as m1 and third value as m2 and fourth value as m3. If you have two variable means you need to find min term from m0 to m3. If you have three variable means, that is x, y, z. So you need to find values for 15. In min term you need to find m0 to m15. So Mnterm is mentioned with the small m and the Maxterm is mentioned with the capital M. The x value is in first row, the x value is given as 0 and y value is given as 0. So in Mnterm you need to write the 0 as the complement of the variable, that is x dash and y dash. M1. In M1 x value is 0 and m value is 1. X value is written as x dash and y is written as it is. For m2 the x value is 1, so you need to return as x, and the y value is 0, you need to return as y dash. For m3 the both the values will be 1, so it will be written as x and y. And for Maxterm it is opposite rule of min terms. M0 is M0 is written as 0 0, x value is 0, y value is 0, so you need to write x plus y. M1 is written as 0 and 1. 0 is written in Maxterm as that variable itself, and 1 is represented with the complement of the variable, that is M1 is written as x plus y dash. For M2 the for x value is 1, so you need to write that x dash plus y value is 0, so you need to write the variable as it is. And finally, you will have x equal to 1 and y equal to 1. So M3 is represented with x dash plus y dash. This is the truth table for Mnterm and Maxterm for 3 literal. The literal is nothing but the variable. So here I will mention the variable with A, B, C. If you have 3 variable means you will get 8 values. So it is how you will find that values. N equal to 3. So 2 to the power of 3 means you will find out 8 values. First is A. You need to fill the first column with 4 0 and 4 1. Second column is filled with 0 0 1 1, 2 0 2 1. Okay. And the final column is filled with 0 1 0 1. In Mnterm, you need to mention 0 as the complement variable and 1 as the normal variable. Write it down the Mnterm as small m0, m1 up to m7. Afterwards, fill the variable or complement of the variable according to these values. So m1 is filled with first a value is 0 means you need to fill the a dash, and b also 0, so you need to represent as b dash, and c is 1, so c is written as the variable itself. Likewise, you need to fill all the values. In Maxterm, it is opposite to the Mnterm. Here you need to mention the A plus B plus C. The first value is 0 0 0. In Maxterm, the 0 means you need to write the variable itself. 1 means it will be written as the complement of the variable. So first row is 3 variable is mentioned with 0. So you need to write the M0 is represented with A plus B plus C. And this second row is filled with 0 0 1. So 0 is represented as A first value, and B is equal to 0, so it is represented as B, and C is 1. Here you need to represent the C value as complement of the C variable. It is M1. Likewise, you need to fill all the values from M0 to M7. This is the Mnterm notation. F equal to A dash BC plus AB dash C dash plus AB dash C plus AB C dash plus ABC. The other way to represent the function of ABC as, so refer that previous value. First note it down this A dash A dash BC. A dash BC is M3. This is M3. A dash BC is M3. So you need to represent that Mnterm notation. M3 plus AB dash C dash. See here A B dash C dash. Where it is? This is A B dash C dash. It is represented with M4. So it is M4. Afterwards A B dash C. So compare with that truth table to fill this value. So that is represented with the Mnterm notation as M5 and this is represented with M6 and the ABC is represented with M7. So ABC means the A value is 1, B value is 1 and C value is 1. The ABC dash means A value is 1, B value is 1 and C value is 0. So this value is 1, B dash value is 0 and C value is 1 here. 1, 0, 0, 1, sorry 0, 1, 1. Or you will write the function of a comma b comma c as with the sigma dot notation in min terms. Function of a comma b comma c summation of m into, so here the common variable is m. You will take the m outside, afterwards fill the number inside the bracket 3 comma 4 comma 5 comma 6 comma 7. So this is the notation of minterm. So this is the notation of minterm. In minterm, the final function of variable is represented with the summation of m of the given values. This is the Maxterm notation. A plus B plus C. So A means here 0. B means 0. C means 0. Likewise A 0, B 0 and C dash means 1. A 0, B dash 1 and C 0. So this will be mentioned. These values will be compared with this truth table, with this column. So ABC is represented with M0. A plus B plus C dash is represented with M1. A plus B dash plus C is represented with M2. Here you need to write it in product term M0 into M1 into M2. So function of A comma B comma C is written as is equal to M0 comma M1 comma M2, or you will represent the Maxterm notation with the as function of A comma B comma C equal to pi of these three values. The M will be a common variable, so take M outside from the values. Afterwards, you will get the value as 0, 1, 2. In min term, the representation will be as summation. That is, it is also called as sigma. In max term, the final equation is represented with pi, pi of m of capital M of 0, 1, 2. So this is the max term notation.